Hello, Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2. Our assignment title is Application on Medical and ECG.
Hi, my name is Muhammad Arfan bin Azhar. Our objective for this assignment is to understand the concept of ECG, to apply filter to remove ECG noise. We are also able to understand how to detect heartbeat from ECG signal and calculate the average heartbeat from the heartbeat. Electrocardiography or ECG has for long has been an important and vital measure of the heart's electrical activities. Using the information obtained from the person's ECG, doctor can assess the risk factor associated to the circulatory system of the body. Conventionally, this analysis is either done manually by doctor or by running signal processing algorithm on a computer. ECG signals are frequently non-stationary, meaning that their frequency content change over time. Naturally, the ECG signal get contained by different noise. In this assignment, we will remove the ECG noise and detecting heartbeat, then measuring the heart rate using an app. Okay, the problem statement. What happens if ECG got noise? The presence of muscle noise represents a major problem in many ECG applications, especially in recording choir during exercise. Since low amplitude waveform may become completely occur, mainly two types of noise are present in the ECG signal. Noise with high frequency include electrocardiograph noise, additive white using noise, and power line interference. Noise, the second type is noise with low frequency, include baseline when break. The noise contained in the ECG signal may lead wrong interpretation.
Hi, my name is Hamza Pradimanikan. My matrix number is B08-191-0237. My part of this assignment is to read out what are the advantages and applications of DSP. There are 5 advantages of DSP, which is DSP provides extremely high precision. As a result, DSP designed filters have finer control over output accuracy than analog filters. The second, the digital implementation is less expensive than the analog version. Third, in an analog system, reconfiguration is challenging since the entire hardware and its components must be replaced. Simultaneously, DSP reconfiguration is relatively simple since just code or DSP programs need to be flashed when modifications are implemented as required. The fourth, the DSP provides a variety of interface types such as UART, I2C, and others to aid in the interfacing of other ICs with the DSP. And fifth, DSP and FPGA may be interfaced. This combination aids in the design of the protocol stack for the entire wireless system such as WiMAX, LTE, and so on. Depending on the latency requirements, a few modules are ported on FPGA and a few on DSP in this sort of design. So the applications of DSP includes, among others, audio and speech processing, sonar, radar, and sensor array processing, spectral density estimation, statistical signal processing, digital image processing, data compression, video coding, audio coding, image compression, signal processing for telecommunications, control system, biomedical engineering, and seismology. So, the DSP application on medical and ECG in DSP. What is ECG in DSP? Electrical activity of a heart is called electrocardiogram (ECG). Fetal ECG represents electrical activity of the baby's heart. It is similar to the adult ECG waveform. A suitable DSP algorithm is used successive QRS complex waveform, and from this, R to R interval is calculated. What is the application on medical in DSP? DSP applications in the medical area include hearing aids, ECGs, and blood pressure monitors, MATLAB noise filtering, fast Fourier transform, bandpass, and FIR filter. Thank you.
Hi, I'm Kivisha Mohan. My metric number is B0820103227. Today I'm going to explain about ECG filtering using MATLAB. This is the code and output that we get for this assignment. For output 1, it's ECG signal before filtering. To create this signal, we load 100 mat. The signal will be loaded to well matrix. ECG signal equals to well U minus 0 over 200. Fs equals to 260 T bracket 0 length ECG signal minus 1 over Fs is for sampling frequency. Plot T comma ECG signal comma R. It's for plotting ECG signal before filtering, and the title of this output is ECG signal before filtering. And this is the signal. We can see the noise here before filtering. ECG signal noise, and we following with ECG FFT signal. This is the FFT signal before filtering. For create this output, we write code ECG1 underscore magnitude equals to absolute FFT ECG signal. This line is to convert ECG signal in frequency domain using FFT function, and then we plot ECG1 underscore magnitude comma R, and this is the plotting for ECG FFT, and the title ECG FFT signal before filtering. And we can see the noise signal here. This is the noise for ECG FFT signal. Then we move to after filtering ECG FFT signal. This is the after filtering ECG FFT signal, and this is the coding for it. For figure 3, number underscore bin equals to length ECG underscore magnitude. Plot 0, 1, and this is the line for before filtering ECG FFT signal, and we use low pass Butterworth filter, and B is equal to order of filtering, and A is cutoff signal, and then we filter the ECG1, and then plot the frequency response, and this is the coding for it. And we also plot the ECG FFT signal, and the title is ECG FFT signal after filtering. Okay, there is no noise here, and here you can compare this filter. This filter is before filtering, and this is the after filtering, and we do ECG signal after filtering. For figure 4, we plot ECG filter. The title is ECG signal after filtering. Okay. As we can see here, there is noise signal, and here we can see there is no noise signal here, and same goes to ECG signal. There is no noise in this ECG signal, while this ECG signal before filtering have noise here. And that's it. This is how we filter ECG using MATLAB. Thank you.
Hi, I'm Rahman Kajashikur. So now I will talk about detecting heart peak and measuring the heart rate. How we will detect heart peak, and from heart peak how we will measure heart rate. So I will explain about it, and I will show MATLAB result. So this is the ECG signal, original ECG signal. If we zoom that ECG signal, we will look the ECG signal is like that. So we will detect the heart peak from here. So how we will detect heart peak? First step is remove low frequency component. So removing low frequency component, we have to follow 3 steps. So this is 3 step, which is change to frequency domain using FFT. Then remove low frequency components. After that, back to time domain using IFFT. And second step, find local maximum using window filter. Third step, remove small values, store significant ones. And fourth step, which is adjust filter size and repeat 2 and 3. So detecting heart peak, first we put original ECG signal. After that we convert it in FFT, and after using filter, so after that we remove low frequency component from here, so it will look like that. So then we use wedding filtering for detect arc. So after detecting it, it will look like that. So again it will filter and it will final result like this. So final result, this is our algorithm final result. So how you will calculate the heart from heart peak? So this is the formula, which is rate is equal to 6 multiplied by sampling rate divided by R interval. So this is the MATLAB calculation. We will put 2 signal. We can see here is average heart rate, first signal, and average heart rate for second signal. So maximum algorithm we take from internet. We will put the reference and we just process. So our main target was like we filter ECG signal, then from filtering ECG signal we calculate heart rate from using some kind of algorithm. So after that I will show coding part from MATLAB. So this is the coding part. We are processed to data simple to demo scale to different situation. So here is for demo 1:2:3. So it means like if it case 1, then it will load the signal 1. Then if it case 3, then it will load plot signal 2. So it will load signal 2. Then did this part, which is for remove lower frequency. So we convert it in a frequency domain. Then we did here, it's for filter fast pass. So we set the sampling rate, and then we did scaling some ECG signal. So after that, here is written minimum distance between 2 peaks. So we set minimum distance for to pick. Optimize filtering for user size here. So then filter the second pass. Here is for algorithm is filter second pass. So we when we detect the RP, then from here we write that RP2 which is we detected already. So when we find the RP, we can calculate the heart rate. So we just write that value and we put RP1 and just we create one formula for calculating heart rate. So this is for like if we write average heart rate in window command, it will show the average heart rate for any ECG data. So this part is for plotting our result, which is here is plot for original data, and here is ECG with the removing low frequency component and filtering ECG fast pass filter as default filters. So this part and detecting the RP filtering size, that plot will figure. So until here, so we will get final result from here. So if I click run button, so it will run. So this is the original figure ECG. Then we convert it in FFT. So after that we remove low frequency. So it will look like that. So for detect RP, it will be like that. And second pass, finding second pass, and here is final result detect RP. So when it detect RP, it will look like that. So that part actually we use some algorithm here. So we picked the RP here. So this is one ECG signal, and this is for another ECG signal. This is the another ECG signal. So this is one, this is another one. So we work with two ECG signals. So if I type here average heart rate on command window, so it will show average heart rate for first signal. So that's all about coding part. Thank you so much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Zulaika binti Jamaludin from grade BEC S11. Today I would like to present about improvement and conclusion about ECG signal. Alright, so in my opinion, for improvement, the development of equipment for the acquisition and processing of bioelectrical human signals, such as the ECG signal, is currently a feasible task. This chapter is a summary of previous work with simple ECG signal processing equipment. So, for the improvement to the work done, we must purchase a greater number of bits. The AD converter supports up to 11 simultaneous inputs and a sampling rate of 32 kHz under certain circumstances. A professional team requires 12 concurrent units. Second, in the filter stage, modify RC filters for more elaborate filters to ensure better discrimination of frequencies outside the passband. So we also must include isolation amplifiers to raise levels for patient safety by isolating the direct loop with the computer that generated by the design proposed in the chapter. Even though the chances of a disaster occurring are low, the possibility exists, and thus widespread use should be avoided before including these amplifiers. So we also must consolidating AD converter routine, readings and displaying results. We must also validate the technical characteristics of the circuits mounted by certifying their technical characteristics. We also must expand the use of this equipment for capturing other bioelectrical signals such as electroencephalographic and electromyographic signals. We also can develop a tool to validate QRS detection algorithm based on the MITDB. So we can use wavelets in the development and implementation of filtering algorithms and waveform detectors. We also can examine alternative methods for parameter detection such as fuzzy logic, genetic approaches, and neural networks. Lastly, we use information technology such as a database to obtain pertinent information about patients and their pathology. So for conclusion of our assignment, finally, this work is an excellent example of the potential application of hardware and software, particularly in the field of biotechnology. The quantity and quality of potential future work demonstrate the validity of the exertion in academic and professional context. Aside from the likely application of this work in medical settings, it also takes into account the scope of work such as ECG digital, which is practically limitless. So, as we know that the ECG monitoring system was successfully developed, uh, the analog signal of the ECG was collected and the digital signal processing was performed in MATLAB. The signal display had a low noise disturbance and a good SNR ECG waveform. The signal data can be used to study heart conditions such as coronary heart diseases, heart muscle diseases, arrhythmia, and coronary thrombosis by analyzing the peak voltage and the time interval between each signal. ECG signal can be improved to real-time analysis for further project improvement. The ECG signal can be captured in real time and displayed on a computer screen. A real-time analysis of the received signal can be performed, allowing it to diagnose the heart condition immediately. So that's all from me. Thank you.